Good morning, everyone. Mark your attendance. So in last class, I think I discussed your different method of dress. So I discussed first method, that is your method of joint, and I discussed second method, that is your method of section. So this both method is very important. So you keep the all the technical aspects of these methods in your mind. So here my next method is method of section. I discussed this method also. So I just method of section. I just give some points you keep in mind for this method. So method of section. Method of section. First point, method of section. So first point of method of section is this method is used for your determinate trust. So both the method is used for your determinate trust. So first point is for determinate trust. For determinate trust. For determinate. For determinate trust. For determinate trust. Second point is this method is suitable when force is to be determined in a particular specified member. So for determinate trust. Next point is this method is suitable when force is to be determined in a particular specified member. So force required in a specified member. Force required force required in a specified member. Force required in a specified member. In a specified member. Specified members. Next is your next is sections should divide the truss in two parts. So you keep this point in your mind also, that In this method, the sections would divide the truss in two equal parts. So if you see this truss, so here I'm also writing that the sections would divide section sections would divide truss in two equal parts. So section should divide should divide divide the truss in divide the truss into equal parts. Truss in two equal parts. Not equal, it not be necessary that equal. It should be uh, in two parts. So section should divide the truss in two parts. In two parts. So here, if you see this truss, so here I just draw a truss. So here I draw a truss. So if you see this truss, here also we have a triangle configuration. Sorry, just here also we have a support here. In support is provided. So here in support is provided. Oh, sorry. Oh, I continue. So here I'm leaving that this truss. So here this is your truss. So if you this is your truss. So this is point A, this is point B, this is point C, this is point D, and this is point E. So if we cut a section here, so if we cut a section here, so just see if we cut a section. So suppose here we cut a section. So here we cut a section. So what happened if we cut a section in this manner, then it will be wrong because this truss is not divided into two parts. Because if you see only this portion, that means only this member is cut, not so many members will be cut. So this section will do not divide the truss into two equal parts. So if we cut this truss in this manner, so I'm cutting this truss in this manner. So if we cut this truss in this manner, here this is our right approach. So what we do, section should divide the truss in two equal parts. So in this part our truss is divided, also in this part our truss is divided. So next point is section should not cut more than three members because we have only three equilibrium equations for solving unknown. So you keep in mind that the section should not cut more than three members because we have only three equilibrium equations for solving the unknowns. Next is section should be cut in a manner that all the members which is cut by section do not meet at a common point. So you keep this point also in your mind that the section should be cut in a manner that all the members each cut by section do not meet at a common point. So after the cutting the section, apply equilibrium equation that you know from your very basic engineering mechanics or strength of material classes, that is your summation of force in x is equal to 0, summation of force in y is equal to 0, and moment about z is equal to 0. Summation of force in x, summation of force in y, and moment about z is equal to 0. So just you apply this equation of equilibrium and you solve the unknowns. Either you choose the left portion or either you choose the right portion. So it's on your choice that you just choose this portion or you just choose this portion. Next, the member in which member force required must be cut by the section. So you keep this point in mind that the member in which member force required must be cut by the section. So these are all about your method of section. So what method of section saying that this method is used for determinate truss. This method is suitable when force is to be determined in a particular specified member. Next, section should divide the truss into equal parts. So here this right this I use this right section, that means this xx section. So this section do not divide the truss into two equal parts, but if you see this black section, that is your yy section, that is your yy section. So basically this section divide the truss into two equal parts. So after dividing the truss, section should be cut in a manner that all the members which is cut by the section do not meet at a common point. After cutting the section, apply equations of equilibrium that you know from your very basic classes. Then you choose either right portion or left portion of the section. Next, the member in which member force required must be cut by the sections. So these are all about your method of section. So if you all solve a problem on this, then uh, you will be able to understand this method of sections. So just solve this question. So solve this question. So this is the question. Just wait. So here I am giving you all a question. So question. This is our question. So this is basically the question. Question. So question is like this. So this is the truss. Here we have a hinge support. Here we have a hinge support. Here we have a roller support. On this end, we have a roller support. Here we have a roller support. So this is point A. This is point B. This is point C. This is point D. This is point E. This is point E. And 10 kilonewton load is acting on this joint E. So this is your 10 kilonewton. So this is your 10 kilonewton load that is acting on your joint E. So just wait, I just erase this joint. So this is the joint E. So this is joint E. This is 10 kilonewton. This distance is of 3 meter. This distance is of 3 meter. This distance is also of 3 meter. This distance is also of 3 meter. Next, this length is also of 3 meter. This length is also of 3 meter. This length is also of 3 meter. Next is find forces in member BC. Find forces in member BC. So find forces in member BC. Just in member BC. In member BC. Forces in member BC. Find forces in member BC. This is the problem. So you have a question. You see at point A, you have a hinge support. At point D, you have a roller support. At point T, a 10 kilonewton load is acting downward. The length of the member, all the members is 3 meter, 3 meter. So this is also 3 meter. This is also 3 meter. This is also 3 meter. So these are the lengths you have given. So just first approach is your first step is you have to find the reactions at support A and support D. So solve this question. I give you all 2 minutes. Just find the reactions. किसी से बना, किसी से बना क्वेश्चन। ठीक है, हम ही बना देते हैं, मत बोलो कोई कुछ। Okay, so I solved this question. So here I am giving you all the solution. So solution. First step is you have to find the reaction. So solution. First step is you have to find the reactions. So here here we just find the reactions. So here here one reaction is acting. Here also another reaction is acting. So we have to find the reaction. So this is our reaction RA. This is our reaction RT. This is RA. This is RT. So what you do? You find this reaction. So by equilibrium equation, summation of force in y direction is equal to 0. You find your all the reactions. So step first is find reaction. So here we see 10 kilonewton load is acting downward. So here the distance is same 3 meter, 3 meters. So here our load is distributed half half. So here we have 5 kilonewton of load is acting. Here also we have 5 kilonewton of load is acting. So Ra is equal to 5 kilonewton and Rd is equal to also 5 kilonewton. Next, what you do? The step second, you cut the truss into part with cutting only 3 members and taking the member on which force is needed. So you have to find the force in member BC. So you cut this truss in such a manner that your truss will cut into two equal parts. So here, if we cut our truss in this manner, so here you see, if we cut this truss in this manner, so here we cut this truss in this manner. So here, this manner we cut this truss and the section is XX. So if you see it, we cut this truss in this manner. So here also our BC member is included where we have to find a force. So BC member is also included, C member is included and ED member is included. So here our truss is cut into two equal parts with cutting only 3 members and also we consider the member where force is needed. So just we take the right portion. If you want to take the left portion, you take from your side that you take the left portion. But here I take the right portion. So it's your choice that you have to opt or you have to go for left portion of truss or you have to go for the right portion of the truss. So I am going for the right portion of the truss. So here we have a point C. So here you see we have a point C. So this is our point C. From this point C, a member is come like this. So this is our CD member. Next, what will happen? Also in this side, a member is going. Also in this side, a member is going. So I just here also from D. So this is your D point. So don't worry. I show you all the member. So this is your this is your roller. So this is your roller support. This is your roller support. Next, here in this direction, our force is going. So also in this direction, another force is going. Also in this direction, another force is going. So this is your force in BC member or force in BC. So this is your force in BC. Now here we have also a force in C. So force in C, F in C, F in C, in C. Here we have a force in C. Here we have a force in DE. So here we have a force in DE. DE. Here it is also, this point is also valid that our all the forces will not, or section should be cut in a manner that all the forces which is cut by the section will not meet at a common point. Here only two forces will meet at a point, so this will going to meet at point E. So if you see this member, or if you extend this member, so here I am extending this member. So if you extend this member, here the member is going to be extended. We extend this member. Here also this member is going to be extended. Here also this member is going to be extended by this dash line. So here we find a point E. So here we find a point E. Next, what we do? So here this will going to meet at a point E. Here we have a reaction force that is of 5 kilonewton. Here we have our reaction force that is of 5 kilonewton. That is of 5 kilonewton. That is of 5 kilonewton. Next is here you take the moment about point E. So what you do here, we cut the section into equal parts. So here you take the moment about point E. So here I am writing take moment, take moment, take moment at point E, or about point E. Take moment about point E. So this ME is equal to 0. Moment about point E is equal to 0. So here, if you take the moment over this point to 0, you find only this RD. So this is point D. So this only you find this R, this point D reactions. So you just find this RD forces into its distance plus this force into its distance. So what happened? So here we get after getting, or after taking the moment about point E, these forces, these two forces, here you see these two forces, these forces, these forces get cancelled, but the impact of this force and also the impact of this force is seen. So what happened here? Just we get after taking moment about E, we get 5 into the distance, that is 3. So here we get 5 into 3. So this is anti-clockwise. This force give also, this force also gives anti-clockwise movement about point E. So this all will going to be added for taking moment about E. So 5 into 3 plus force in BC, force in BC into the perpendicular distance, that is 3, is equal to 0. So what we get? We get 15 plus 3 into FBC, 3 into FBC, BC is equal to 0. FBC is equal to 0. So what happened? So here force in BC comes out to be -5. So this is force in member BC. So this is -5 kilonewton. So if you see the sign convention, or if you see the representation of your force, you take your force tensile. So here this force is compressive. because if you find the result or if you get the force in BC as minus 5 kilonewton, that means your consideration or your assumption is incorrect. So you take minus 5 kilonewton as positive. So this is the correct force direction. So this is the correct force direction. So this is force in BC. So this is force in BC, and here I am writing force in BC is minus 5 kilonewton compressive. So it is compressive. So C stand for compressive. So this is all about your method of section. Next is find the member force in your CD. So this is next question. So you all solve another question. So you solve next question. So everyone solve another question. Find forces in member CD. So this is our next question. Find forces. Find forces. Find forces in member CD. So this is a truss. Also here another member is meeting. Here also a member is meeting. So here a member is meeting. Also here a member is meeting. These are the points. This is point A. This is point B. This is point C. This is point D. This is point E. This is point F. This is point F. These are the distances. This distance is A. This distance is also A. This distance is also A. Here a force is acting, that is your P. So here a force is acting, that is P. Here another force is acting, that is your 2P. So you have to find the forces in CD. So find the forces in CD. This is point D. So this is your point D. So find forces in CD. So what you do, you just observe this truss. After observing the truss, you find we have zero force member. That means we have a zero force present in two member. That is in AB and that is in BC. So here in this, so here in this truss we have zero forces. Also in this member we have zero forces. So these two member we have zero forces. Then what you do, you just cut this truss in this manner. So you cut this truss in this manner. you cut this truss in this manner. After cutting this truss in this manner, you get this member is cut, this member is cut, and this member is cut. So three members will be cut. Then you apply method of section and then cut the truss in two equal parts. Then you just consider the upper portion of truss. Do not consider lower portion. If you consider the upper portion of the truss, then you find in two member you have zero force. Then what you do, you just find the forces in member CD. So just apply summation of force in x direction is equal to 0. Just you apply summation of force in x direction is equal to 0. Summation of force in x direction is equal to 0, and find the member force in CD. Also, this member is cut by this section. So here, if you find the forces in CD, then you get this FCD is equal to P kilonewton. This force in CD member is equal to P kilonewton. This is P kilonewton. So this P kilonewton is in tensile. This P kilonewton is in tensile. So these are the type of question framed or asked in your member of section or method of section method. So in next session I also solve one or two problem and then discuss a very important concept of zero force member or force member where zero force is present. So just join in next session and continue that session within 1 or 2 minutes. So I think also your 40 minutes is going to be over. So just join.